Okay, welcome to another episode of HVAC TV. I have a guest here, Sean Kelleher. Am I saying that right, Sean?
That is correct. Well done.
Awesome. Well, hey, I like the way this is starting. Let's end the show before I screw something up. But
Perfect.
Sean is with RLS, Rapid Locking Systems. And today, before Sean introduces himself, we're going to talk about something we don't talk about very often on the show, which is the installation side of the equipment. And I was just, getting ready for the podcast, and I was thinking, okay, we've got the design, we've got the manufacturing, we've got the sales, the submittals, the installation, the maintenance. And then I thought, it's a miracle any of this stuff ever works, ever, because of all the things that have to go right to make a complex, especially a complex commercial HVAC systems work properly. And, the aspect that Sean's here to talk about is, we got a lot of pipes in this business, whether it's a residential unit, even a small refrigeration, ductless split system, large chiller plants. There's a lot of pipes with stuff flowing through them, and you need to connect the pipes in the field, and there's various methods to do that. Some are, take longer than others. Some are more prone to having problems than others. And, I love innovations that make things simple and easy. And Sean's going to talk about one of those and something that's very popular in industry today. So I guess if you're like a design engineer, it's kind of important the different techniques of connecting pipes and installing equipment. We have a lot of engineers that listen to this program. A lot of contractors listen. Of course, it's very important for them. Maintenance folks, building engineers, service techs, etc. I personally am not a tech. I grew up in the sales side, but I was telling Sean, my last experience with installing and brazing refrigerant pipe was in the 80s with my dad. And it was like in an attic, and it was 150 billion gazillion degrees. So Sean's laughing if you can't see him on the video here. But anyway, I'm going to shut up. Sean, why don't you introduce yourself, and then we'll get to some questions here.
Yeah, good afternoon, everyone. Tony, thanks for having me on. I'm Sean Kelleher. I'm the Director of Engineering here at Rapid Locking Systems. I've been working on this product specifically now for over 13 years. I actually started when I was hired on at a sister facility. I started on the design side of this. I could do 3D CAD, and they needed 3D modeling for the first three sizes of the fittings that they were looking at. So the 3/8, 3/4, and 7/8. So I've been working on this pretty much from day one. It was about 6 months into development when I joined the team. But since then we've taken it obviously from R&D to commercialization. We just ticked over 10 years on the market in the press, HVACR press space. I oversee new product development, technical support, quality assurance, pretty much anything. Anything technical, more or less, will come through me. And so I've got a team here that I obviously work with as far as design and tech support is concerned. And so we're out here trying to help our end users be as effective in the field as possible as they might want to be, right? And from a speed and safety perspective. And while press in general is not new per se, very common on the water side, right? After 10 years, I finally think the HVACR press game is starting to get that adoption, which is great. Great to see. So really happy to be on. Looking forward to the chat.
Yeah, I want to ask you, the most common problems you see in refrigerant piping is the biggest thing, right? Like getting that right, making sure the interconnecting piping for split systems, especially with VRF, is important. But before we get to that, you left out one very important piece of your bio, which I hear you're like a Star Wars guru, celebrity podcast host. Tell us about that. That sounds like a lot of fun. Nothing against press fittings. I'm sure that's fun too, but what's going on with your Star Wars podcast? How about a plug for that?
Sure. So in our spare time, as which we have so much of, me and a buddy, we have a
between 1 a.m. and 4 a.m. Is that when you record it?
I typically it's typically 10:30 and 1. Yeah, actually is pretty much when we do the recordings, and then the editing is from 2 to 4.
There you go.
But we me and my buddy John, Jedi John, and my moniker is Obi Sean. We have the Force Diet podcast, and it's a Star Wars.
Wait, the
Star
Force?
Wars
say that again.
The Force Dyad. Podcast.
Dyad. Okay,
Yeah.
that's a nerd Star Wars term that I'm pretty nerdy, but I don't even know that one. So you're gonna have to
Yes.
explain what that is.
So that is from that is a mention from the sequel trilogy, which is basically dyad is a connection in the force between two separate individuals, but that their bond in the force is so strong that it can basically be sensed universally. So in the sequel trilogy, it was Rey and Kylo, but we do dyad just because it's the two of us, and
I
so
got it.
it's a play on two.
So bringing two things together, it all fits into the podcast.
It's all connection.
It all is coming around.
It's
that wasn't even planned.
It's one big circle. It all comes back to itself. It circles back on itself. So yeah, we've been doing that for about 4 years, and it's been a little while since we've been able to record. But
I get it. Yeah, it's hard.
It's a nice little outlet for sure.
Good.
Away from work and everything like that. So yeah.
Well, that's good to hear. I'm glad you got a little plug in for that, and we had a little fun with that too. So, okay, let's get down to some serious business, right? Like, so interconnecting piping in split systems, VRF. So that's, if you're new to the HVAC industry, or maybe you're a designer and you're not familiar with a lot of the installation aspects of equipment, that's the part of the job that's the most critical in terms of this type of equipment, right? If you don't get the piping right, especially for VRF, you're really in big trouble. Even for a split system, a lot of times we have jobs with very long line lengths. If you don't get the piping right, you don't get the oil back, and those jobs never seem to fix themselves. They're just problem after problem. So the piping is extremely important. That's the point of this. So if you're listening, make sure you do work very closely with the manufacturer's rep to get your pipe sized properly. If you take one thing away from this, don't run the pipe just based on the stub out. Don't run it based on that size, because that might be for a 20-foot run. And if you got 80 feet, that pipe size is going to change. So that's my public service announcement before we get into this part of it. But from your experience, Sean, what's the most common problem you see? Let's just focus on refrigerant piping first, then we'll talk about water. We can mix them all in. It doesn't matter.
Yeah, I was going to say that typically, we'll see. Yeah, the mix of refrigerant piping, whether it's refrigerant piping or water piping, it seems to be, I'm not going to say it's interchangeable, but there does seem to be some commonality there. And, on our side, what I'll typically get more feedback on is, tube prep, right? So tube prep's the biggest thing from an installation perspective as it relates to like our type of product.
You're saying tube prep?
Yeah, tube preparation.
Okay, gotcha.
Yeah. So obviously you've got your lay lengths, which are critical to design, making sure your pressure drop is properly accounted for and everything like that. So like you said, you get your oil and all your stuff back where it's supposed to be and not stuck somewhere in the line. But for us, as far as the press side of things, there's more, I guess, emphasis or importance on the preparation side. Whether that's clean pipe, in our case, a deburred pipe, both ID and OD. ID I know is more critical, like on the water side, but it's seemingly universal between the two. So that way when you're connecting to a clean surface. That's for us. That's the biggest sort of feedback.
So let's say, Sean, I'm going to stop you right there just for a second. So a lot of the terms you're using, our audience might not be familiar with them. So I want to make sure. I'm going to give it a go, and then you say, you're an idiot. That was wrong, Tony. Here's what that really means. So first of all, let's talk about the oil. So refrigeration systems have oil in them. In a package system, it's all pre-engineered and designed. You have to worry about it. But what happens is oil compressor needs oil, and that oil can go out into the interconnecting piping, and you could pipe it in a way that creates traps or doesn't have the proper velocity to get the oil back to the compressor. So all that is very important from an engineering side. So if you don't get the oil back, your compressor burns out. You put another one in, a year later it burns out. You put another one in, a year later it burns out. Then by number 3, you're like, maybe we should look at the piping, and then you start looking at the piping, and and that's not an uncommon scenario what I just laid out. So that, that's another reason why it's important to get that engineering right. Now you're talking about the pipe prep. So when you cut a piece of pipe, and I actually helped my son's a technician, and we installed a couple split systems next door in our new home little office area here. And, when you cut the pipe, it crimps it somewhat at the end of the pipe. So you have to scrape out or deburr the inside to make it smooth. And then you're saying that outside is just as important with your press fitting that you're going to put on there. Is that correct?
Yeah, that's correct. And when you're running traditionally like line set tubing, right, which would be annealed or softened tubing, you'll get more of that roll down on the end, as you described from
roll down. Okay, I wasn't familiar with that. Okay.
Roll down taper. You might, right. So you'll get kind of that reduction on the end, right? Whereas if you're using hard piping, typically what'll happen is you'll have a slightly raised lip. After you use a tube cutter, it will be slightly raised on the end. And so by deburring the outside, you'll chamfer that front edge of the tube. So that way, when you insert it into the fitting, it doesn't catch the O-ring, it doesn't slice the O-ring, or seal the gasket.
And that is in your fitting.
That's in the fitting, yeah.
Is it plastic or?
No, it's well, that's not going to show up because of the shadow. Well, you can kind of see it,
yep.
Right? So it's a rubber gasket.
A rubber gasket. Okay, got it.
Yep. So it's a fairly resilient material. But I've seen tubing that has had the OD and the ID deburred to the point where this front edge becomes like a knife. And so it can catch that O-ring. However,
so could you show that piece of pipe you had again to the audience? So what we're talking about is, do you have one showing a joint?
Actually,
right there. Okay, so what you're looking at there, if you're not familiar with this, is you got two pipes coming together. You got to join them somehow. Brazing's one way you do it. This is another way to do it, right? So this fitting itself, do you have a fitting you could hold up as well, Sean?
Yeah, sure.
You probably got a whole box of them over there.
I do. Yeah, I've got quite a few samples around here. Here, I'll just hold this one up, which is actually one of our new reducers.
Perfect.
But yeah, so one of our new 3/5/16 reducers for the new OE systems that are coming out.
Pipe goes in one end, the other end, and then you have a tool which presses
which naturally I should have had one of those handy. I can run and get one. I can run and get one.
It's okay.
But yeah, it's if your listeners or your viewers are aware of like water press, like a plumbing press, whether it's like Viga or Nimco or what have you. It's a similar type of system, but our press jaws that go over the end have a different profile. But in the space, it's a similar concept, right? So the tube will go in, and then you'll press.
And it's like a giant clamper.
Yeah.
Very powerful, very strong.
Yep. And so the jaw simply sets over, press a button, pull a trigger on the press tool, and it presses.
Yeah.
So it's about a 7-second cycle time, a 7 to 10 second cycle time. So each end you're done in 25 seconds. Whereas, traditional Braze, depending on size, can take a minute, bigger pieces might take a couple minutes, depending on what it is that you're making your connection to. So, yeah.
So explain to the audience the Braze process, like just to put two pieces of pipe together. What does that involve versus something like this?
Sure. So, and I'm not going to pretend to be a brazing expert. It is an art to be
it sure is. Yeah.
An excellent, it takes a lot of time and effort and practice.
By the way, if you're new and you're listening to this and you like to post stuff on social media, if you don't have 10 years experience doing good brazes, don't post yourself brazing on social media, because you'll get some comments.
Yeah. And so my experience extends to the lab only in assembling samples and stuff like that. So I have brazed, but by no means in a crawl space, next to wooden.
Right.
And I props to all of the installers who do that day in and day out. It is an art form. But as far as like general purpose, general practice, you would get a braze coupling or solder coupling, seem to be used interchangeably. You would have your same piece of pipe, right? You would install the piping onto the ends. Typically, you would end prep in a similar way. You would make sure the ID is cleaned out and everything like that. And then most, and again, my knowledge here is limited. Most solder today or braze has some level of silver in it, whether it's 5%, 15%, 30%. which, that, from a material aspect, right, you've got your oxyacetylene gas, right, oxygen and acetylene gas. And then one of the big things is you have to flow nitrogen through your braze for refrigeration. And so this is necessary for every braze joint. And the reason for that is you have to remove the oxygen from the connection. So when you heat the metal, if you just allow the air to cool it, it will create oxide on the inner and outer tube surface. And so flowing that nitrogen through helps prevent that, because if you have oxidation and oxide in your tube ID, that can come loose as the refrigerant flows through it, and it will clog your filters. It'll clog it can clog your valves, which over time will cause your components to break down and your systems to fail. Right. So it's important that with brazing that you have to flow the nitrogen through to eliminate that oxide formation. With press fittings, you don't have that, right? You don't have that heat element. You don't have that oxide risk. And so you don't have to worry about that, that aspect of the installation affecting things long term. So that's one of the big areas that press and braze differ is you don't have to do that nitrogen purging with every fitting that you install. Like that is every single joint. And so again, depending on size, and with what you're brazing, time wise, you've got time savings as well. But the big one is the cleanliness for your system long term and long term system performance, and not having to worry about that. Right? If you do the nitrogen purge, then you don't have to worry about that. But I have seen tubing sent back from the field that did not have that done, and you can see the oxidation inside the tubing. And again, long term, that will damage your components and affect your overall system. So,
yeah. And what do you say? To me, it seems like, oh, well, that's a lot of good stuff. What's the biggest objection you hear from folks who've been in the industry a while? Hey, I've been doing it for 20 years this way. I don't want to change. Cool. Respect. I get it. Some might feel it's got a better chance of hold just because they're familiar with it and they have that experience. And some I've heard comments like this, and I don't know if this is true or not, but there used to be a product called RefNet. And some people will comment, I've been through this with RevNet, I'm not going back. Explain what that is. I don't really know. I remember it was out for a while, then it went away. That's not this product, I don't think. You explain to me what the difference is there.
Sure. So RefNet was so it's termed an axially swedged fitting, and that's a fancy way of calling it a compression fitting.
Okay.
So it was I believe the body was made of steel, stainless steel, and it had a ferrule and a compression sleeve, and it would be installed over the pipe. And there was a tool similar to a lock ring, if any of your listeners or viewers are familiar with lock ring, but it had a tool that was kind of like a fork, and you would place the connection in, and it would hydraulically pull that connection together. It was a compression fitting, basically, right? So the way that you would use a screw type compression fitting to drive the ferrule down into the compression sleeve, same concept, only with a lot higher pressure. Well, it was used primarily to connect aluminum tubing, and so you have steel and aluminum, and they don't get along. And so galvanic corrosion over time would destroy the tubing and the systems. So the big difference, again, with this type of system, and again, Braze would be similar because it's a copper fitting to a copper tube, is that our fitting is made from the same material that the tubing is, right? So you're going to have no risk of galvanic corrosion.
Same expansion rates.
Same expansion and contraction rates.
Right.
All of that stuff is the same. And so it's not like RefNet at all. In that, the long term.
And that wasn't your product. I just want to make it clear.
No,
it was a completely different company a long time ago, right? Yeah.
Yeah, and I believe it was actually a couple people who used to work for Lockring that went out and started their own business.
And I think the move there was to try and use aluminum instead of copper for the piping because it's a lot less expensive. It doesn't weigh as much, things like that. But I don't think that ever really caught on.
No, and that was so that would have been, I think, 2015, 2016. I remember when there was a big push to maybe try and substitute copper for aluminum because it was pricier at the time. But yeah, there was a string of those failures that proved problematic. So, but yeah, like the biggest questions to go back to what you originally asked, there's a lot of questions around strength. There's no, people are familiar with water press. And the pressures in a refrigeration system can, depending on the fluid, go as high as 650 psi. Not including CO2, right? So your traditional mainstream refrigerants, right, which is significantly higher than your residential water systems would go, or even commercial water systems. So there's that, and then there's longevity questions, right? It's a new product going into a well-established market as far as HVACR is concerned, right? Most, if the question we always have, is, well, how long will it last, right? And we've had fittings now installed in the field for 13 years, going back to like the earliest ones that we would have done, kind of in the prototyping days, if you will, with no like field calls about, hey, I installed this 10 years ago and now all of a sudden my system's leaking. We don't have breakdowns like that. I mean, all the testing that we did for our system, as far as cyclic fatigue, accelerated frost, defrost, salt spray, etc., was meant to try to simulate as best we could, traditional system, environments. And so, but yeah, longevity, people ask about the gaskets, right? Even though gaskets are in all sorts of different components, whether it's your compressors or your filters, or filters, your valves, that sort of stuff. One of the things about our system is how we press will isolate, right? So there's enough compression here in the bands to hold out the atmospheric pressure. So you're not going to get degradation from like ozone and that sort of stuff. So really all it's exposed to is what's in the pipe, which is what the seal is designed to interact with. It's, and the actual exposure to the O-ring is very little. We don't have one of our cutaway fittings, but on the backside of the O-ring, there is a very small amount of surface area that's actually being interacted with. And worse, over time, you might have swell or that sort of stuff with the interaction with the fluid. But because it's captured within the groove, there's nowhere for it to go. I mean, it's there, it's captured. And as we said earlier, the expansion contraction rates of the material are going to be the same to the tube. So as this expands, as the tubing expands, the fitting will expand and vice versa. So that you don't lose that connection point over time as you might with, another system, or even something like, a Braze material, which will have other filler metals in it, which will expand and contract at different rates, which over time can crack, right? But yeah, so
right. So there's no perfect solution to anything in life, and there's engineering trade-offs to all these different things, and our best answer we can come up with in our engineering community is it depends. Which is better? Well, it depends. If you're doing here's 50 things here and 50 things here, and for these scenarios it might be better, but that's all good stuff. So I was wondering, A2Ls. Mildly flammable, whatever term you want to use. I was thinking that, this will help with that. But I'm thinking, well, you don't really braze when there's refrigerant in the line anyway, that I could think of. So does that really play into the choice whether someone would use this or not? What are your thoughts? Have you heard any of that? Or
so as far as the new fluids are concerned, you're probably not doing a whole lot of repairs on a line that's full of gas. But you would potentially have to evacuate, some of the fluid to do those repairs. Whether there's a concern around residual
Oh, okay.
fluid in the
Makes
lines,
sense.
but no, like that actually hasn't really come up a whole lot as far as like, oh, well, I'm not typically brazing while there's, while it's pressurized, which of course
Right.
you're not.
Right.
You're also not going to do a press connection or press repair in the same situation. But not having to, not having to worry about evacuating the whole system or even a large chunk of the system. If you can isolate just the line that you need to work on, you don't have to worry about residual fluid
Nice.
in the line causing an issue there. So that would be one, I guess, pro or at least talking point to that question about that situation. So
Are manufacturers using this that you know of? I'm trying to think
um,
of most of the manufacturing products that I've seen, and I'm not in the field every day, but they usually seem to have Braze in the factory. Any movement towards using something like this in manufacturing? Have you seen any of that? Or
so the OEM usage, it is something that with a product like this, and it's not just our product, but like
mm-hmm.
press for HVACR, at the OEM level, things are so cost conscious, right? And most lines, the lines that I've been in to see, like I've been to different OEs and seen kind of like their setups, and there are areas that we can be used in, but it's not sort of a broad usage the way it is on the commercial and the residential side,
Mm-hmm.
with installations. Doing, in connecting those internal components, it's also very kind of space prohibitive. Everything's kind of tucked in there so nicely and neatly that even if you do a lot of your installation offline and do your subassemblies, you still might have challenges with some of the clearances and stuff like that. And so, whether it's space related or cost related, OEs, there are certain exceptions to that, of
Mm-hmm.
course, but generally speaking, in the areas that we've tried to go in for OE, it's been challenging for those
Right.
two main reasons. Yeah.
Because the tool does require some clearance to get
Hmm.
the jaws in there and the clamp and the back of it. And
Yeah.
you don't have the flame to worry about. You don't have to worry about burning up stuff either. That's another side of the brazing we didn't talk about is keeping
Right.
things cool
Mhm.
and not letting the flame hit other parts of the equipment, but just like the heat transfer through the copper, if you're near a filter dryer or a valve or something like that, you got to be careful. I mean, I'm assuming near a filter dryer, you don't want to get that too hot either, but so there's that side of it. But again, there's pros and cons to all the, you
Right.
know, you're an old school mechanic and that's the way you've always done it. And you got 5 years left. I probably wouldn't change either. I'd be like, man, I'm going to roll with this. It's been working for me for 40 years.
Yeah.
I
Exactly.
totally
And
get it. I totally get it.
yeah, and with equipment like with OEM stuff, there is a big push. We're trying to help um, persuade OEs to become more
Mm-hmm.
press
Sure.
compatible or press ready. And there are OEs that are starting to do that, off their main components, like off their compressors and off their valves, moving away from those swedge connections. Which again, you could still braze those, right? You just have to get a coupling instead of doing, tube to tube, right?
Mm-hmm.
But it does allow for those who do want to make those connections with press able to, without having to worry about one, cutting the swedge off, which obviously adds time, but two, not necessarily maybe having enough tubing after you do that to make your connection. Um, so that is a space that we're trying to be more proactive in as like a partner to end channel users, is trying to convince OEMs that, hey, there's a benefit here. Like, people are adopting this, people are moving this way. Not in, it's not like the market's going from braze to press, right? Like, that's
Right.
not it.
Right.
We're an alternative. And so, but trying to have those options available for people who do want to use it on, when they're connecting their their components, is one thing that we're trying to help facilitate as much as we can. And we are seeing some OEs start to move that way, which is nice.
Got it. Well, we didn't talk about water piping, but water piping. Fill in the blanks, right? Like, so,
Yeah.
so what is the size water pipe you can use? The a press fitting in general, what's the size water pipe you could go up to with that?
So it would be system dependent, meaning manufacturer dependent. So speaking for us, we have solutions all the way up to 2-inch water pipe,
Got it.
and then all the way down to 1/8 inch, which I don't
Mm-hmm.
know that you make 1/8 inch water pipe, right? Which would be 1/4 inch ACR. So our size range is 1/4 to 2 1/8. And we can facilitate anything in between that. Um, and so, but yeah, so that is one question we do tend to get sometimes, as far as like people who are traditionally water press installers, right? Trying to not necessarily figure out what tube to use, right?
Mm-hmm.
But one, can we be used on water, right? So there's that, and then two, people who are used to pressing water who then press our system incorrectly, because of how the jaw gets placed. But for our system, or at least for water press in general, um, there are requirements as far as like the O-rings and the codes, certain approvals, whether it's NSF or something else that makes you allowable for potable water.
Mm-hmm.
Our system can be used for non-potable water, so like chiller systems, hydronics, that sort of stuff,
Right.
drain lines, etc. But if it's going into a system that someone's drinking or bathing in, then we're not that solution. There are half a dozen other really good options for that installation. Our focus is on the HVACR side of things.
Got it.
Yeah. So,
Cool.
but you do see some people who are starting to make that, not the switch, but add in HVACR to their traditional like water installation side of things. So you will have some questions about that from time to time.
Got it. Okay, so you have a YouTube channel, RLS Rapid Locking Systems. I saw it on there because I looked up before the podcast because I didn't want to look like a total idiot. Although I can do that no matter how many videos I watch sometimes. But so there's that. And then I'm sure you have a website, and people buy this. If you're a tech and you're listening, you buy it from your local supply house, I'm assuming. Is that how that typically works?
Yes. So we've got numerous distribution partners, regional, of course,
Mm-hmm.
that an end user, an end contractor could walk into, and purchase the product. It's the same thing with tools and jaws and stuff like that. I do know that we're currently going through like a website overhaul to try and make it more user friendly and everything like that. But our current website, rapidlockingsystem.com, does have the information that someone looking to get into our system would need. As I said at the top of the show, I'm in tech support and stuff like that. So if you have questions, reach out to me, and I'd be able to help with that. But yeah, walk into your wholesaler, your local wholesaler, and you should be able to find it. If you can't, have your or have your wholesaler call us, and we'll get them set up, and we'll send stuff up. We're able to typically fill orders within 24 to 48 hours, depending on like what it is. So turnaround time's pretty quick. I know
Where are you headquartered?
Yeah, so we're just outside of St. Louis, Missouri.
Oh, okay.
We're in the town of city of Hazelwood, but we're about 20 minutes from downtown St. Louis. All of our manufacturing is actually, for your viewers, right behind this wall here, is our manufacturing floor. We got about 80,000 square feet of manufacturing space. So
they're actually made here in the States?
Yep. So every fitting that is on the shelf is made right through that wall, or right behind that wall, I should say. Our old facility was in a sister company. We moved here about 3 years ago. Actually, 3 years ago, July. Actually, we're actually celebrating our 3-year anniversary at this location. But we were in Shelbina, Missouri, which is about 2.5 hours northwest of where we are currently. So the parts have always been made in in the U.S. And so, yeah, every piece we've ever made has come from here in the U.S.
Very nice. Well, that's good to hear. Okay, Sean, anything else before we finish up here and you go get on your Star Wars podcast, the dyads or something like that? Is that what it was?
The Force dyad.
The Force dyad. There you go.
Yeah. No, I mean, as I said, our goal here is to offer a system, an alternative system for people who are maybe looking for ease of use, speed, safety. Take your pick. As we move forward, with the new refrigerants, I think there will be a benefit to having press alternatives. We continue to make sure that we're testing our stuff as needed to make sure that we're ready for these market shifts and everything like that. We're developing new products to be ready for these system adjustments. As I said earlier, the new reducer, the 3/8/5/16 reducer, has been, kind of came out of nowhere, right? But that shift to that sizing coming off a lot of the VRF mini split units. And so, celebrating 10 years, like I said, this year. Looking forward to, 100 more. Let's go with that. Let's be big and bold and just say 100 more.
There you go.
Yeah. So.
We'll say it. We won't be here anyway, so we won't be able to.
That's right. That's right.
Have to
get fact check.
That's right.
I'm gonna have some AI bot fact checking me in 75 years.
That's right. Hey, if we're lucky, at least we'll be remembered a little bit, right?
That's right.
There you go. All right, Sean, thank you so much. We appreciate you being on the show, and hopefully you'll come back and give us an update in a couple months, and maybe I'll get to see you in Vegas. We were just talking about the AHR show. I can't believe that's coming up soon, too. And thank you for joining us today.
Of course. Thank you for having me on, Tony. It was great. It was a great chat. Looking forward to the next one.
Thank you, Sean. And thank you so much for listening, HVAC TV. Please go check out our YouTube channel, which is also called HVAC TV. That actually makes more sense that a YouTube channel is called HVAC TV, but the podcast is too. So we try to keep it simple around here. Anyway, thank you all for listening. We appreciate it. And thank you, Sean. Have a good day.